You ever stop and think about what actually happens when you click a link? I mean, it feels totally instant, right? But behind that one little tap is well, it's an incredible journey. So let's do it. Let's follow that message and see just how far it really goes.
Yeah, seriously. Every single click, every tap, every swipe, you're basically firing the starting pistol on a high-speed invisible relay race. And in the next few minutes, we're going to follow that baton, that message across the entire globe and all the way back.
Okay, so where does a journey like that even begin? Well, it starts right where you are, with the very device you're using right now. Your phone, your computer, that's our digital starting line. So, in the world of networking, that device, your phone, your laptop, whatever it is, has a name. It's called an end device, or sometimes a host. And it's a pretty big deal because it's the start and the end point for pretty much all network communication. It's where the message is born and where it comes home to. And this whole thing works because of a really simple relationship. See, your device acts as what's called a client. It's the one that asks for stuff, like a web page. And then, somewhere else out there in the world, there's another computer, a server, whose whole job is to provide that information. It's just this constant back and forth, a digital conversation that's basically, hey, can I see that? And the server saying, yep, here you go.
All right, so our message is ready to go. It's got its running shoes on, but before it can hit the open road, it has to get out of your house, right? It has to leave your local network and connect to the great wide world.
And to do that, our little click needs some local guides. These are what we call intermediary devices. Think of your Wi-Fi router or switches and firewalls. They're like the traffic cops of your local network. They don't create the data, but they're absolutely essential for directing it, telling it which way to go to get on the main highway.
And that's a perfect way to think about it, actually. Your message starts out on the local streets. That's your LAN, your local area network, like your home Wi-Fi. But to get to its destination across the country or even the world, it has to merge onto a massive system of interconnected highways. And that's called a WAN, or a wide area network. So now we're there. We've made it to the big one, the global superhighway. Our little piece of data is officially out on the open road, traveling across the internet.
You know, the crazy thing is, the internet isn't a thing. It's not one single entity. It's this gigantic worldwide collection of all of those LANs and WANs we just talked about, all interconnected and talking to each other. And maybe the most amazing part, no one owns it. Not a single person, not a single company. It's a global team effort, which is kind of incredible when you think about it. So how do we get on this superhighway? Well, you're almost certainly using one of these common on-ramps right now. It could be your broadband cable, DSL through a phone line, your cellular connection, maybe even satellite. Whatever it is, that's your personal link, your entrance ramp to the entire digital world. Of course, for businesses and large organizations, the on-ramps have to be a lot bigger. They need these super robust connections, like dedicated lease lines or high-speed Ethernet WANs, because they're handling just a massive amount of traffic from maybe thousands of people all at once. Okay, so you can have a global highway system with trillions of messages zipping around without some rules of the road, right? It would just be total chaos. The internet is exactly the same. So let's talk about the 4 core principles that keep this whole thing from falling apart. All right, here are the big 4. Fault tolerance, scalability, quality of service, or QoS, and of course, security. You could almost think of these as the fundamental laws that govern the internet. So let's dive in and break down what each one really means. First up, we have fault tolerance. So imagine you're driving and the main highway is suddenly closed for an accident. In a fault-tolerant system, your GPS just finds you a different route, right? The internet does the same thing. Your data gets broken up into these little pieces called packets. And if one path gets blocked, the network is smart enough to send those packets on a different route. This is huge because it means one little failure somewhere doesn't bring the whole system to a grinding halt. Next up is scalability. Think about this. Every single day, millions of new devices and users log on for the first time. Scalability is what allows the internet to handle that massive growth. It's like being able to add new lanes to the highway on the fly without slowing down the traffic that's already there. It's designed to expand. Okay, number 3 is quality of service, usually just called QoS. And you've definitely experienced why this is important. Ever been on a video call and it just freezes? Or you're trying to stream a movie and you get that dreaded buffering wheel? QoS is the solution. It basically creates an express lane on the internet highway for the really time-sensitive stuff, like video and voice calls. It gives them priority so they get through smoothly, while other things, like an email, can afford to wait an extra millisecond. And last but absolutely not least, we have security. This one is, well, it's massive. This is all about protecting the network and, more importantly, protecting your information as it makes its journey. You can think of it as the locks, the security guards, the armored cars, everything that makes sure no one can intercept your data, steal it, or mess with it. And believe me, the threats are very real. You've got external threats, things like viruses, spyware, hackers trying to steal information, but you also have to worry about internal threats, which can be anything from a lost laptop to an employee accidentally clicking the wrong link. A secure network has to be ready for all of it. So how do we protect ourselves? Well, we have tools. For most of us at home, that's going to be things like antivirus software and a firewall. But for larger networks, they bring out the big guns: dedicated firewall systems, something called intrusion prevention systems, and VPNs, which create these secure private tunnels for data to travel through the public internet. So that's the incredible journey of your click, at least as it stands today. But just like a real highway, this digital one is constantly under construction. Things are always changing. So let's wrap up by looking at a few huge trends that are really reshaping this whole landscape. I mean, think about how we work and live now. There's bring your own device, where we're all using our personal phones and laptops for work. We're doing online collaboration with tools like WebEx, connecting teams from all over the planet. Video isn't just for fun anymore. It's a critical communication tool that eats up bandwidth. And of course, there's cloud computing. All our data and apps don't even live on our computers anymore. They're on some remote server. Every single one of these trends puts a whole new level of demand on the network. And this whole journey isn't just about our computers and phones anymore. The network is literally weaving itself into our homes. With smart home tech, your calendar can talk to your oven. Your lights can talk to your security system. It's connecting everything, really blurring that line between our physical world and the digital one. So from a single, simple click, we've gone on a journey across the globe and back, all in the blink of an eye. The network connects our world in ways that were just science fiction a few decades ago. It brings us all closer. But as it gets more and more integrated into every part of our lives, you have to wonder, what new challenges will it bring tomorrow?